Hello. Just gonna do a little extra stream today. I did a little bit before. Fixed some of these spans here, they were a bit off. And I'm trying to find an issue about identifier not found. We get a span error report, but then it just aborts here, so we need to figure out how to handle this error here. Let's see. So it happens, well, yeah, that's right. We get the error in result type for this binding declaration. And we're trying to resolve the type. We get this identifier which is not found, which is because of a typo here. So then we report a span error, or report an error there, and then it returns the error as well. So then we need to bubble it up and catch it somewhere. So we need to catch it somewhere. I think we'll catch it in the binding declaration, and we will simply. Actually, I think we just do a fail here. In this case, we do have a second option. We could take this type actually, but I think we just try to make this a failed type actually in result type. Yeah, that we can do that instead of. Oh, I'm in the wrong thing. So we're trying to resolve it, and this should be like a failed type now instead. So if we didn't find it, instead of returning this error, we can do failed. Okay. Okay, now we get unsupported type expression instead. Why do we get that? Okay, type my strings not declared. Okay, and then we get a failed type. So B has a failed type, and then we're trying to assign this to it. And we're running some type expression here. I think I'm gonna add which type expression to the logs so we can more easily see that. So we're gonna take this and go to run type expression. Oh, we already have this though. Wait, what? So why are we not seeing that? I see it's failed. Okay, so it's already, yeah, it's already there. So we're running this. Why are we running that from run binding declaration? Okay. So first we're resolving the annotation type, right? So that should already be like processed. Then we're running expression on the initializer. Then we get the type expression, which we do there. Oh, and then we run. So I think what we need to do is we don't want to run it if we get this, because that's already processed. We only run this one, right? I mean, technically we could run it anyways. We just need to add a failed here. Yeah. Now it works. Cool. Okay, now we get this proper error message. No, type expression. There we go. Okay, let me check. No? Is it running? So why is it not running the thing? Now it's attached, okay. There we go. Now we get this one. And we change it and it works. Okay, cool. And we do this and we get this other error. Alright. Nice. And then we try to say 5. No. Did it detach? Is it spinning? No. So why do we not get errors now? Well, we get a parse error. What? Or what's happening? Next token, try to match file against B. Send JSON. Oh, this is the matcher, right? The matcher. Okay. Diagnostics is empty. B equals 5. So we did change new text. B equals 5. Okay, so why is that not resulting in an error now? assignment expression. Materialize, binding type, validate type, assignment, fail. Oh, because this is like a fail type. No, it's not a fail type. It is my string alias. Okay, let's see what's going on. Yeah, okay, so validate type alias, and then it's done. It thinks. Okay. Oh. I see. There's nothing in here. Why did this happen? Okay, so we resolved the alias type. Do we have this one? Okay. Yeah. So we don't so we don't have support for this yet. Right. We need to implement this function. This is what's missing here. We need the scope, get scopes from span function, to be able to get the scope where the alias lived. And then we can look up the name of the alias. Now, I'm thinking maybe, I mean, couldn't we just store the type on the alias? I know I explored this before, but it feels like we should be able to just set. Like, where do we create the alias? Yeah, here's the only place we create the alias. And we do have a lookup for it here. So we should get the type that it should represent. And we could just store it here instead. So that we don't actually have to make a scope lookup thing, but we do. But we still would want to have that function though, because of the completion thing. So yeah, we still would want to have the lookup, but yeah. Or I guess we could just run a partial type check up until the position, perhaps. Nah, we could reuse the reuse the results we already have with the thing. Okay, well, I'm not sure why I didn't do this. There was something that told me not to do this. We got a binding, so this is the binding ref, or the binding, yeah. If we don't get a binding, we have a failed thing. I guess we still have an alias, but it's like a failed alias. Well, it's not really an alias then if we didn't find what it should alias. Not sure why I opted not to do this. I don't remember now. Well, this is optional. Except it's not optional though. Oh, I see. We can find a binding, but it's not certain that it has a type this expression. That's why. Hello, Penguin. Welcome back. I think the reason why I didn't want to have a type expression here was that all type expressions, including this, is constant. And we cannot actually change this. I think this is like, okay, we can use this as kind of like a quick lookup, but if this was not found, then we get a failure, basically. I think what we do is we force it to be there, and if we don't find it on the binding, it's gonna be a failed type expression. Yeah, that's what's gonna happen. So either we get this or we get a failed binding. So this would be the actual type expression. This would be this, or else it's gonna bind to a failed expression. And then we can use that over here. Yeah, so now the alias should have a type expression that might be valid. And here we resolve the alias type. And we don't need to do this anymore. Well, not yet, maybe. We'll see. And you should actually get something now. So yeah, we just return the type expression. Now it might be a failed type expression, but it is not optional anymore. And all right. Okay, now what? Okay. Unresolved type literal. Okay, so we're trying to validate assignment and we get an unresolved type thing here now instead. How and or why or how. So we go in here and we validate again. Okay. So now this, oh yeah, so that should now be, okay. This should be like, hang on, 1 second. No, that should be the string. Oh, maybe it's put to, okay, it's alias to a string. But the string itself also needs to, it's also an alias, actually. So we need to like we need to like go even further. Actually, it's actually also an alias. So what's happening? Okay, let's see where we create, or no, yes, where we create the alias. We get this type expression. Now this type expression is either the binding, which should exist at this point. If we look at the thing here, so it's gonna try this one first, or it's gonna, yeah. So it's finding this in the scope over here, which is set to string in the binding. So string, but string is just an identifier. So that is also technically an alias. So when we create this type binding, we should actually probably make this into an alias as well. So we should have like run type binding. And here we're just declaring, we're just taking the type expression as it is. We should make it, we should resolve it into an alias. We should actually resolve it before. resolved type expression. Now we could check if it's identifier. I think we just do resolve type actually. And this will do that. And then we use this instead, resolved type expression. Wait. Okay, let's do that. There we go. There we go. Now we get it. Okay, cool. There we go. Except, you know, it says byte here. It should actually say string, or it should say my string actually. But the problem is we don't really carry the alias through to the error message, because the error message happens in validate type assignment. Let's see, we don't really carry like a context with us here. That was like the original type or something like that. Like when we go to first, it validates my string against the number. So it goes in here and it like resolves the alias type, but then it calls type assignment again with the actual type. But here we kind of lose the context of the alias. So we don't really bring my string with us. And I'm not sure if, you know, I mean, it's good and bad, I guess. Like, would you want to see my string here or the actual type? Like, this is the actual like representation of the type, of the actual type. String is just an alias for array of bytes. But I guess it would be nice to see string here or my string. I don't know. Whatever, let's just have it like this. Like we could try to bring the context with us to be able to show like what the alias was in the beginning. I mean, I guess it's better. I guess it's better in a way because if let's say this was more complicated type that was like a struct with a whole bunch of fields, you wouldn't want this whole struct information in the error message. You would want the actual, you know, alias type or the alias string instead. So okay, well, I guess while we're talking about, we can just as well do it. I think it's just, you know, we just need some extra context here. Let's just put like, I don't know, options. I usually just add, when it's like random extra things, I just put, I usually create an options thing that we can use to get that. So let's have like binding alias, which is a nullable expression alias type. It just needs, I mean, it really just needs to be a name, but whatever. We could keep this around here. All right, and then, yeah, but that's it. Let's add a function here. I would just say like with alias. And Yeah, so now you have to have options, but we can just say dot empty to have like nothing there. I usually just have like dot, you know, if you put options you can do like dot curly braces, but I don't know. Yeah, let's just do that. It's gonna get like the default options. Unused, yes. So I mean, do we need to bring it into every one of these now? I've been thinking also of changing this interface a little bit, like changing the pattern here so it's more manageable. It feels like it's very, I don't know, it feels very like, how would you say it, like yeah, when you do change like this you have to change it everywhere. There's no real way to put this in here without changing everything. I mean, I guess once we have this in here, we can just add more things into the options if we would like to have more context. We could also call this like validate type context, but then that would also change between the things. I guess there's really no way around it. We have to add it basically everywhere. So I'm just gonna make a macro or something. I mean, it's really just adding the options here, going to down. But now we have to change all of these. So really, we could maybe do oh man. Actually, you know what? Let's do this. Let's make a macro here. And we'll search for validate. And I will grab that into the search register. And wait, did it actually change now? Or no, it didn't. Okay, hang on. Search for validate. Copy this. Search for the thing. No, don't do that. Search for the thing plus pub function. There we go. Now we can go 3 down, add options, validate type assignment options, exit, go 4 up, start, done, done, done. Copy this. Search for no, this is that not the thing we want? God damn it. Oh, it's like this. There we go. So now we're back. And now we can go down and there. There we go. All right, cool. And now, yeah, all of these are unused. We also need to pass them in here. Also, oh yeah, in the case of this, actually, we need to check if we need to get like the passed down options, and we want to check if options binding alias is null. We want to set it to assignee. Ooh, but that's not a pointer. Okay, well, I guess we have to make it a pointer. And then we pass those options instead. There we go. So now the first alias that we encounter, we're gonna fill that in so we don't see some weird type. All right, now anytime we have these and anytime we have that, we also pass options down. Wait. No, you don't actually have it. What the hell? We might need it. We're not using it here. Okay. Here we could just pass it down. And okay, well, here you can see also a report assignment error. So actually, report assignment error, we also want to add the options, because then we're gonna use those in the error message. So we're gonna use the alias instead. Instead of expected, we're gonna put whatever alias we had. So if options alias, we get it. Otherwise, we do this. Now we could probably do this a little bit better, but I'm just gonna do this now. So this should have a name, expected type, alias, actual F. Now I do realize that actual could also have an alias. Like this could also be an alias. So we should actually have assignment alias as well. And let's call this binding alias. Let's just remove this. There we go. Right, so now we need to pass options into this. And also no, this would also be formatted. Yeah. We could just do F on everything. Actually, let's have one there. But we just need to check expected is if options binding alias This won't really work because it's a different type though. Okay, maybe we can have the thing in here. Options, binding alias, or else expected. But I don't think that will work because it's not the same type. But this is, you know, this tuple is an any type. No, that won't work. I don't think this will work. God damn it. I don't want to have 4 different branches here. But I guess maybe we have to. I mean, I guess also what you could do is you can make a new struct. No, we need to make 2 new structs actually. Binding, formatter. And it's like, okay, well, this is either, this is gonna be like, oh my god, this is so convoluted here. Let's see how far we get here. So let's make a function that is, it doesn't need to be public actually. Let's make this function format is gonna return a type, which is a struct that has a format function that will format. So this takes like the optional. Can you do question mark any type? No, I don't think you can. Let's do any type, and then it takes the fallback, and then the format will do if. No, hang on. No, those are these need to be types. I guess maybe they don't need to be type. We could do type of. If we got optional, we do try writer print format, and then we get it as well, and we return. Otherwise we do try writer print. All in the effort of not having to repeat a thing 4 times. Bear with me here. So now now we can create 2 formatters. So we'll do formatter.format and then options, binding alias, and expected. And here we do formatter format. Actually, I'm not sure if this is gonna work either, because well, let's fix the rest of these anyway. You need options. No. Materials binding type. Where is this call from? Run assignment. Okay. You don't really, I mean, yeah, the options. Now this is like the entry point. So we'll do that. Because then if this is an alias or that is an alias, it's gonna, you know, it's gonna bind into here. Okay. What is this? Alias. Oh yeah, so now you need to do that. Here we go. Hang on. You need options. Okay, there we go. Now let's actually do. I guess we have to do like comp time is a. Well, I mean, no. I think the standard JSON formatter does something like this, where you call this format function, and it gives you this struct. No, it gives you an. Yeah, okay, so it gives you this struct like it doesn't give you a type, it gives you an actual instance of the formatter. Yeah. I'm just trying to. Maybe I could use. Maybe we could use the union enum. But then we're back to the same thing, really, because the type, we still need to create a new type. So I think what we need to do is actually, if we remove these, no, okay, so we don't have this. These need to be types, yeah. They need to be types, unfortunately, I think. And then we don't have default values. But we can have an image function. which returns this. Yeah, I would rather do like an exercise in exploring the options instead of repeating myself a bunch of times. I'm just allergic. Okay, so, but you could argue what is more productive, you know, in some cases. But I don't know. Sometimes I like to do this kind of weird stuff anyway. So let's, because it could be used, you know, you could bring this pattern out and use it. You know, whatever later. So actually, formatter, I mean, this could be a function as well. We could just make this into a function actually. I'm just gonna call this like the fallback formatter, which returns a type, and we will take that, put it there, return this struct instead like this. There we go. And now we can do binding formatter is fallback formatter, type of optional binding alias, type of expected, and then we do, and also dot init with these, and here we do assignment formatter, dot init option, it's options actually. There we go. Yeah, and now we can say binding formatter assignment formatter instead. There we go. Okay. Now we go back to the, okay, well, actually, I guess we could try it out now. We start. And there you go. Now it says my string instead of int. However, if we did it like the other way around, which we we could, I guess, we could make C my string, and if we would say, let's make, well, also we're trying to assign a constant, which we don't really have a, we don't have a rule for that yet, but let's make d is an integer, and apparently we don't get like the LSP stopped working. But let's say that c is equal to, actually let's try this, let's try double. So now d is equal to c. Okay, so now that should result in, okay, we get unsupported type expression. Let's just fix this first. Where is this failing out? I think it's the 5 here. This is unsupported apparently. Let's fix that. Run type expression. All right. From what? Run literal. Okay. String. Okay. So integer. Wait, how is it unsupported? Wait, run literal should be fine. So where are we getting back to? Run expression, run binding. Okay, let's go to run binding. We don't have an annotation. And then we get the initializer result type. Expression result type. So yeah, that would be like, wait. No, expression result type. So that would be the literal integer. So AST. Right, that would be this one up here somewhere. Literal integer. This one just calls. Well, I guess it does this. So we should get an integer type at this point. Yeah. So this should be the integer type. And then we're running that. And we get it. So that's where we end up here. So I think for like literals, we should just pass through. We do have string though. String literal. Type expression. No, wait, that's it. Okay, no, this is wrong. Oh yeah, we don't have that. Okay. But we do have array. We do have array, okay. And I guess array would kind of be, well, let's just not do the array right now. Okay. There we go. Why do we just get one though? We should get two. We should get here as well. So apparently that succeeds. Okay. So C is my string, D should be an integer, right? If we try to set B to D, we should get an error. No? Okay. Okay, I think maybe we should get a thing now, which is the in the LSP where you can inspect. You can inspect the type of something. So if you hover over it, because I want to see what the result is here, and I realized that hey, the LSP could actually help me debug this a little bit. So what we need to have is, when given like a position in the file, we need to find the scope of that particular place. Each position here should correspond to one scope. Not uniquely, but there should be only one in the like the deepest place where this is. So this whole file is one scope. And then there's technically could be like scopes in these bindings, but I think for now this is just one scope though. And we could hack it as well and just say that, hey, it just returns the global scope, and that's what you get right now. But we could also create, like we could also do the actual implementation of it to find the actual scope where it is. Because I don't think it's gonna be super difficult, to be honest. If we go to the type checker and we go to scope. No, get scope from span. Here we go. Get scope from span. So this function is what we need. And this would give us a scope. We should always get a scope, to be honest. Otherwise, there's something really wrong. I mean, I guess the type checker could have failed, or yeah, okay, whatever. Let's suppose we could get nothing back, I guess, but okay. So then we have self type checker, and then the span. Okay, so let's say we're given a span. I mean, we don't even need a span. We can have like a position, a location actually. Where is that? No, it is here. Oh, the token. Okay, I see. Token location. Okay. So actually, let's have location, because this denotes a file, line, column, offset, you know, everything we need, except we might not have the offset, but we should always get like line and column, because that's how the LSP is kind of, it doesn't work with offsets too much. It works with lines and columns as far as I can understand. All right, so once we have that, I'm gonna call this from lock instead. And yeah, first we need to get the document, or the, yeah, so we have modules. So we need to get the module that corresponds to location file. So we get that. If we don't get it, I guess we return null. Then we don't have it. But now we should have a scope. We could just return this to get it working right now and start working on the LSP to hook it up. But I don't think it's going to be that difficult to get the actual scope though. There are a couple of steps involved, I think. We could first like sort by line, or like not sort, but we could, yeah, we could find by line basically. The scopes themselves don't actually have, you know, they don't have a span. They should have a span, because if they don't have a span, how can we find it? They need to have like some kind of location. And I think it's always going to be like some kind of coherent thing. Even if there's a bunch of islands, you could create a parent and have a bunch of scopes that has the parent there. Yeah, okay, so let's add a span. There we go. Although, how would we define the span, though? I guess the top span would be the whole file. Actually, maybe this is kind of difficult, because when we create the scope first, we don't really know where it ends. I don't think. We have to get to the end first. Wait, no, we should have, if you have the AST, we should know this. Yeah, we should know like the scope, like if you have a block, yeah. So actually, okay, so we need a span here as well. No, that's wrong syntax. Okay. Sometimes my brain just goes on autopilot into like TypeScript, because that's what I used to work with. Okay. Great. Now we have the spans. And like the spans are always like you have start and end. And it's like a line. So you have a started line, end line, start column, end column. So I'm thinking like if we can just find all the spans that are in a certain line, and I guess then try to go as deep as we can in the like some kind of depth thing. I mean, you could like index. I wonder if we could maybe just return a list of scopes also, or because I'm not sure if you can have multiple scopes. You know what? I think this could be more of a thing that I anticipated. So I'm just actually gonna abort this a little bit. I will try to add the spans here, because it would be cool to actually get that in, because I think that is needed for us to actually be able to see where they end up. Or I could just not have the spans. Actually, let's just undo this. So, because it could be that I'm during, you know, I'm thinking about this in the back of my head, and then I find some other solution that is better, so then I have to backtrack and redo everything. So I will just remove that for now. It wasn't that really much, instead of adding more that I need to remove later. And then let's just actually do what I said first. Let's just return this module. So we just return the top scope of the file, because right now we don't really need to have it work, but I will add a to do here, implement finding the correct scope. Yeah, because if you're in a function, for example, this won't really know about the local variables in the function or in another block, and if else, for loop, whatever, any kind of block scope, you wouldn't see the things in the block. So but yeah, we would see the top scope now, but we need to also now fix this in the LSP. So let's go to the LSP server, because we do have like a completion handler thing. No, it's not the completion. Let's wait with the completion. I want to do... Okay, let's go to the LSP documentation actually. This is gonna blind you a little bit, so... Wait, where is that documentation? Oh, here we go. Yeah, I'm turning on the bright mode now. 1, 2, 3. There we go. Sorry about that. Did change text documentation. No, so we want to look for I think language features. It's something with like a hover. Yeah, there we go. Hover. The hover request is sent to request hover information given at a given text document position. Proper name, text document hover, property type hover, client capabilities defined as below. So I'm gonna check what we say our capabilities are. I'm just gonna read a little bit here. Client supports following context format if the content property refers to the literal type markup content. Order describes the preferred format of the client. I can show you here. I made this type in Zig, the capabilities here. So it's fully like Zig typed. And here we like, yeah, have all these things defined. We have completion provider. And you can add a bunch of things in here. If you're making your own LSP, I would recommend having this here. You can actually go to the GitHub and copy this thing here. It's not perfect, and it has kind of a little bit of workaround with some of the TypeScript types that are not fully translatable into Zig. So I made this special type when you have some types, or not some, well, is it called some types? Yeah, it's called union types in TypeScript anyway, where you have like, it could be this type or this type. So I made a special type called either, which you can see here, either, which does the job. So, but let's see, workspace, no, what was it called? Hover provider. So here you can see, in order to actually create this, you have to do payload, and then you would, okay, no, I don't actually get completion here, which is kind of stupid, but if we go to this, we don't find anything because it's not, here we go. So this is either a bool or hover options. If it's hover options, we have work done progress. Is that it? No, it can't be. Did I not do this correctly here? Hover client capabilities. Oh, it's the client capabilities. I see. Oh, I see. So the client can request, can like send, okay, I want hover capabilities and I have this content format. I'm just gonna ignore that and just return, you know, markdown anyway. Okay, I'll need to show you here. So basically here you can see server capability. So this is what we are defining here. It is a bool or hover options. And the hover options is basically nothing. There's nothing here except for work down progress, which I don't really know what it's used for actually. Like all of the capabilities almost have this, but I'm not sure what this means. I guess they explain it here. So I guess it might be if something takes longer to make, you can add this here, and you have like true. I'm gonna set this to false maybe, and just, I don't know, go with it. So actually we just set this to true. Wait, actually let's just set it to true maybe. Wait, what does that mean actually? Set it to true. Hover options defined as follows. Request hover option defined. Contents and range. Okay, 1 second. I'll be right back. All right, let's see. So here we are, a result of hover request. So this is what we should return. Now I believe that, yeah, we just return like a string. What's a marked string? It's just a string. Could be, okay, so it could be like a language deprecated. Use markup content instead. Okay, fine. And what is that? Kind or markdown. Okay, okay. So we could do that. We could just send markdown and it would hopefully just work. Range. Optional range is a range inside a text document that's used to visualize the hover. Huh. Okay. Well, yeah. I mean, I guess we could actually, because we do have the range. Yeah, we have this. So let's see. Wait, integer. I didn't know this was a thing. Okay, so okay, it's just a number. Right. Okay, but what does true mean? I guess we'll do payload and then it's like work. No, what was it called? Hover options or something like that. Yeah. So the way it works is basically if you have an either and you get two types in here, it's gonna get you're gonna get a union enum where the fields are named the same as the types that you provide, except they are like lowercase at the first letter. So here we have hover options. So I have to type hover options like this, and now I can say, you know, work down progress equals false, I guess, and that should be a thing. We don't get LSP help here because the LSP doesn't know how to work with the comtime types there, but we do get compiler, you know, the compiler what is this formatting here? Yeah, there we go. Okay. So, hover provider, hover options, work down progress false. I guess this would be equivalent to having, yeah, this would say that, yeah, now we have hover provided, but now we also need to support this. So now if we go to like did change, for example, we have to add a thing here for that. So let's go, I don't know, here maybe, and it's gonna be, is it text document hover or something? I don't know. Where is this defined actually? Oh, I see. I haven't added it yet. So let's check what it's called. Wait. No. Hover. Text document hover. And that is, so the name here has to match because I have this thing that looks at the actual field name to match the method, like the request. And this will be hover parents that we don't actually have. Wait, these are types. Oh, we don't have hover type. Okay, so I didn't add those. I didn't add all the things. I only added the things that I used except for the capabilities. All the server capabilities I added almost 100%. However, the parameters for request and stuff, I only added the ones that I actually used. So hover parents, and then you get text position work. So we got work done, and we've got text document identifier position. I'm just gonna copy this, and it was like hover parents, right? So let's do hover parents equal to whatever this is. And I did have like macros and stuff for translating the documentation here, since there was a lot of these, but I think yeah, there we go. I do need to do some. Also, they have like tabs. Okay, there we go. Text document identifier. So we already have this type, so that we don't need to worry about. Yeah, it's just the URI, and the position we also have already. Okay. Was there any documentation for this? No, there wasn't. Okay, cool. There we go. So that's the hover params. So we should have that now. I could just go through and add everything here, but no. Okay, now we can add hover. Cool. Except the auto completion, the fill in doesn't really work there 100%, so whatever. Right, so now we do request ID. I guess we need, do we need an ID for this? Not sure. I think all of them have IDs, maybe. The response doesn't say it needs to be an ID though. Well, let's just keep to the tradition here. These don't require us to send anything back, I guess, but this one does. So I will copy that. Initialize. Yeah, same thing. I think whenever we need to like respond, we need to have an ID. Probably. Okay, so let's just do handle hover ID params. Where's the params? Oh, it's here. Yeah, so now this is the hover params. Cool. Could not handle hover. I mean, should we really return an error at this point? I don't know, I guess. Okay, now we need the handle hover function. Okay. So, handle hover. Yeah. Let's go to the workspace. We need to figure out so we need to figure out how to get the type checker here. Now the type checker is actually done. It's actually done over here. So let's search for type check. Right. This type checker only lives when we actually report the type check. However, I think that we can actually live with having a type checker in the whole workspace. The whole workspace could share a type checker, actually. Or we could also run, I guess we could run a type check every time someone does the hover, but that feels very inefficient. Because you might not have changed anything and we should cache the results. Yeah. And with the type checker, we basically get two things. We get a list of diagnostics that we put forward, or and I mean, And we get also the scopes with all the variables and everything, so that we can actually get some context of what we're doing, and supply like auto completions, hover information, type information, go to reference, you know, all that good stuff. That is gonna be supported by the type checker. The type checker is gonna provide that for us. So basically, I think that we should store maybe the type checker on the workspace itself. And whenever we need to like rerun the type checker on a document, we should probably add support in the type checker to kind of clear that document. Or we could just clear the entire type checker and rerun everything, I guess. We could, that could also be a thing. I'm not sure actually what's the good, because we would want to keep the diagnostics from other files around. No, yeah, we could just add. We could add a something that would clear out a document, maybe, even if we need it. I guess we'll find out. So let's do this instead. Let's not initialize this here, and or deinitialize it. We should actually get it from the workspace. So we add the type checker here. Okay. Now the allocator. Okay, so we are creating an arena. And I think that's good because this allocator, I'm pretty sure, is not an arena, so that should be fine. Okay. Now, because it's an arena, it's not really suited for long-term processes, so it's kind of weird that we are putting it in here as an arena here. So it's kind of going against in what I believe here, because this would basically memory leak. Yeah, unless we kind of clear everything out. Unless we like clear everything out, it's gonna keep on growing. This arena is gonna keep on growing. Maybe we could add another mode or something to it. No, man. Is there a way to check? Also, we don't need to have this entire thing. Is there a way to check, like, query capacity? What if we set like a maximum limit or something, and it reaches the maximum limit, it would just reset? I don't know. I guess the problem is really with the language itself, because the issue is that this language does not have like a project structure. There's no project structure, so there is really no entrance point to it. If you open a file, the file could potentially be included from anywhere on the entire file system. There's no such thing as like a, you know, a project, so to speak. I mean, you could potentially scan the whole file system to find a file that imported the file you opened. But, because it's just going to be quick and dirty Runic scripts. And it's just going to be like the file you open is the file that's going to get scanned. And potentially any files that are imported as well. Those are also going to be scanned as well. So I think maybe it's fine if we like rerun this every time you open a file or something. We rerun this thing here. So it's not gonna feel like a super smooth thing, like a super smooth, you know, LSP regarding the error reporting, because you have to kind of open the file again to see the errors. If you switch to another file, the previous files errors are gonna disappear unless they are opened by the, I guess if they're opened by the client, we could like run all of them unless they are already ran in the type checker, I guess. If they're already in there, because it does keep a cache of the modules that has already been checked. So yeah, I guess we don't really handle that. We don't handle running type check on a thing that already has been checked. Do we have that actually? No, we just create a new scope and we put the thing over there. So we basically, we don't check if we already have it. I think we should. I think we should just check if we have it first and return the cached result. And then it's up to the user of type checker to actually clear a document if it needs to be rerun. Yeah. We need to like have a invalidate thing. So let's add this as a cache check first. So let's do like get or put. And we have the arena, we have the key. The key is duped here, which is kind of bad. Actually, I don't want to dupe this here. Let's just do, isn't there a has or get key? I guess we could get and then check for optional. I thought there was like a has. Contains, there we go, contains. So if we contain the path, if, can this return an error? No. If we contain the path already, we just return get path, and there we go. Should be done. Now, we don't store the diagnostics though, but maybe we don't need to because the document didn't change. Yeah, it's only on change that we need to do that. And then we should also have like invalidate document, which doesn't necessarily need to rerun the type check, but we just want to remove it from the cache basically. So this would just be modules remove. Okay, let's just do a swap remove. And there we go. That's it. So when a text document changes or is opened or closed, well, actually, if it's closed, we don't need to do anything. But if when it's opened and when it's changed, we need to invalidate the document and then do the type check. So now we can actually go back here. Where's the thing? Right, so we do the type check. Actually, we also need to do invalidate as well. Yeah, we don't need the allocator anymore. Cool. Oh, right. Here we are. Oh. I see. Okay, so let's wait with that. And then in it. Oh, wait, where? Okay, we could just use document store. There we go. Yeah. There we go. Because it's it has the pointer, so it has gonna be the same pointer. Okay, cool. Okay, now I think that's it. Actually, now we can just reuse the. We have workspace, and then we have type checker, and we could just get scope from location. We just need to create the location. So we have like file. It's gonna be params URI, except it's not URI. Is it? Is it URI or wait? Man, I always forget which thing we're actually using. We're using path and not URI. I think describe path. What? You know what? I'm so tempted in putting this into like update of another function. It's just gonna be so many things though. Whatever, let's just do it. What is self? It's the document store, okay. So what do we need? We need self. We need a document. And we need events. And what is events? It's that. Okay. Do we need anything else? No? Alright, so actually we need to, okay, so let's get the text out. I guess. There we go. Okay, cool. Just get rid of that whole thing in this function here. Okay. Great. Okay, so I think this is gonna be like, wait. So we got URI. Do we have like URI to path or something? Resolve URI path returns absolute path from the URI. So we get the path. I think this is what we need. We need something else now. Okay, I guess we will have to free it as well. We don't need to keep it around, so we have to free it. This would be path. Okay, and then we have line. I think. Yeah, line colon offset. We don't have offset. I'm gonna say offset is 0. Line is position line position column, or actually it's called character, I think. No. Yes. And actually we have from find index here, so we could actually find the index. However, we don't actually need it, to be honest. So I'm just gonna say, you know, say it's 0, and then we'll just assume that it's 0 at this point. All right, and then we get the scope. If we don't get the scope, I guess we have to return like an empty thing. But we should always get the scope at this point. So unless the module is not there, in which case we could potentially try to do a type check on it. Actually. But anyway. So let's see. So basically what we do now is we create a result, which has to be some kind of result. So basically this is the initialized result. Where is the other results? Result response. Wait. Send initial, say completion result, completion list. Right. We have to just look at what the type is here. Where is that? Hover. Here. Hover. Request response. So this is the response. Hover. I'm not sure if we actually have this, so I'm gonna copy that. Go back to types. Search for hover. No, we only have options and params. So I'm gonna add maybe here. You know, this thing here. Contents is, well, I'm just gonna say markup content. Do we really need it? This is deprecated anyway, so I'm just gonna say markup content here. Okay, now we have the type that we need to create, so let's create that type. So we get the results. It's going to be hover That's kind of the payload of the response. And we have contents is gonna be, well, okay, we're not done yet. We need to look up the location. So we have the scope. Now we need to look up the location. Wait. Oh yeah. I guess we'll just loop through the scope. If we have the scope, we will loop through the bindings. Why do I not get completion? What's going on? Oh, because of this. Items. Wait. Oh, values. Values. Binding. I mean, also we could. I mean, okay. Well, it's probably better to look up by position, but technically we could also look up by the identifier that is under the cursor. That could also be a thing, because then we could just use scope lookup, or yes, lookup, and we could produce the name here to look up the name in the scope if we can get identifier from the cursor position. But we could also just go through each binding and check if we are colliding with the cursor, since we have all the ranges stored in here. So let's actually do that. So we have the binding. The binding has, oh, we don't actually have the span. Well, I guess we need to add it. Okay. Oops. Yeah, that's just, we need a span. Maybe this should be identifier, actually. Yeah, let's just change this to identifier, and this is identifier, because the identifier has a span and a name, so that's perfect. And let's provide the identifier instead. And there we go. And you are identifier. Okay, now we should have a whole bunch of places where we need to fix in the project. Definition. Oh yeah. These things. Okay. Well, let's do identifier, and then you will be, you know, name is name, span is global. Okay, and you are now identifier. There we go. Type binding recursion identifying. Yeah. Oh, okay. So now we just do this instead. There we go. Same thing here. Same thing here. That was an easy fix. Okay. So now we have identifier. And we have a span. And we should see if this contains the... Actually, you know what? I'm not sure if this is 0 indexed or one index. I don't remember. I know that we have to we do some juggling with the numbers here, but I guess we'll find out what we need to do here. All right, so you are the line and you're the column. Yeah, so I'm just checking if the span contains the line and column, because we already have this function here which does the job, so easy peasy. And I just realized that we could do the same for the scopes. Actually, we already have this functionality, so we could potentially find the correct scope as well, but kind of easily actually, but whatever. Let's just do this first. If we contain this, I guess we're done. We will break with some kind of binding. Do we get a shadow now? Is this a shadow? No, it's not. Okay. If we don't find it, we should have a null. Okay, cool. Right. Actually, we could do... Actually, we could do this. Kind of like a weird thing here. Alright, I think we need two else's. It looks very weird. It's like the first else is for the if, or this else is for this if. It's like if we have a null. This else, this for, we have this else here. Okay, so then this is like, well, this is a, no, it's a semantic scope binding null. But now the type kind of messes everything up. Whatever, let's do this. It should understand what type it is, but anyway. Okay, so now we could get a binding, or we can't, or we don't. So if we didn't get anything, we should have some kind of contents for that. The range is gonna be the range. We don't really know what the range is. I guess if we get a binding, does it know what this is now? No. God damn it, that's annoying. Could do that. Scope binding optional. Okay, now we get the type. Now, binding, okay, so we have these things now. So the range would be, wait, we should have span. Oh yeah, we have span. That should be the identifier span, right? Yeah. If we don't have the span, I guess we just return, you know, whatever. We could try to find the identifier span of whatever you're hovering over. I don't know, but no, let's just return span. Wait, is there a way to turn this into a range? Yeah, I think we have this actually. No, we don't. Or do we? Yeah, we do have from span. Yeah. From span. Otherwise, also you can see here we actually have this thing. Position. Let's also add to location actually. From location and to location. Which returns unique token location. Well, I guess we don't have the file though. We need the file as well. Offset. Let's just do 0 for that, whatever. So this would be like int cast from, I think this is an I64, so, but I'm just gonna bank on the fact that it's not, no, it's a U32 actually, okay. But yeah, we need to add one. Okay, but now we have a, now we don't have to like manually do it every time. So now we can say, for example, up here we actually do like location is position to location instead, and then we actually need to provide the path. So now we have the location, and we can just supply the location now here, and then we can use the location there. We could also have contains location for even more convenience. We can also, okay, let's do some file equality as well. I'll just check start. They should have the same. There we go. So it's checking if it's the same file and if we contain the thing. So now we can just say contains location, location. Okay. Where are we now? We have the binding. We're trying to build a range from this span. If we don't have the span, we can do like from location maybe. So we get like a 1-by-1 thing. Actually, this should be token. Yeah, it's just gonna be this actually. So we'll just take the original location and have that as the range. Binding shadows. Oh yeah. Sure. Otherwise, or yeah, so now we need contents as well. So what I'm gonna do is I need to think a little bit about how to. I thought of just doing an allocating writer. It's probably the easiest way to do this. Yeah, sure, why not? Let's just do like a writer allocating. I actually like this more and more. And now we can initialize that. This be, well, actually this would be like alloc writer. And this would be written. Alright, so now we can just write to it and we should be good. Actually, this is bad. No, it's not bad, because we're at the end of this, we're gonna send this away so we can initialize all we want. Okay, so right, so now I think we're gonna say if we have a binding, we now write to the thing. Otherwise it's gonna be empty, so I think if we didn't find it, we're gonna say you know, write all I don't know, couldn't get any info, sorry. No, but I guess like something went wrong. The classic cop-out answer there. If we got it though, what can we do? So we have type expression, which does have a formatter, so we could format the type we could like print I guess the identifier and then the type. That would be something maybe. We don't really have documentation or anything like that, so do you have a format function actually? No, you don't. Or I mean you. No. Okay, well, whatever. Name, and then we have the type expression, which should have a formatter function. It's optional, so we have to put a question mark there. And not sure if there's going to be a problem if it's a pointer. I don't think so. All right. I guess we have to try doing that. If this fails though, I guess if it fails we don't do anything. I mean, then it means we can't actually write to the thing anyway, so we should, everything should just go to shit by that point. What's this? Oh, unused, okay. Well, it's gonna change now anyway. Markup content found, oh yeah, okay. So actually we need to do like, kind is marked down, and value is alloc writer with, okay, and then we're gonna look down. I think we just do this. We send the JSON, we make a response with this, with the ID or so. Yeah, that should be it actually. Yo, what? Welcome. How much of this did you know beforehand? How much have you learned on the go? I mean, yes, it's kind of mixed. I've done a lot of like parsers before, and you know, tokenizing, parsing like an AST into an AST and doing stuff with ASTs and stuff, but I've never done a type checker before, and this is the most advanced LSP I've done before. Also, I've never like written an LSP by hand, you know, like this before. I've used, you know, I think there's like a nice in TypeScript there's like a nice thing that I think Microsoft has done. I mean, I think they are kind of the authors of the LSPs, and there's like a nice TypeScript library that you can use to create your own LSP. But using it in Zig is kind of, it's not really that difficult, to be honest. You just have to read up a little bit on the protocol, which they have documented as well. Pretty nice documentation as well. So yeah, but the type checker is that's entirely new for me. Okay, so now potentially we will be able to hover on bindings in the topmost scope to be able to find information about it. So if we jump to this arrow, type LSP restart, we get a crash. Okay. Yeah, this is now document not parsed. Okay, so this might have something to do with, so type checker 290, document not parsed, workspace type checker type check, I think, yeah. So okay, let's just go through the flow a little bit here. So we're creating the type checker, and we're using it here to run the type check. We're invalidating the document, which removes it from the type checker cache, which should be what we need to do. Before that, though, it should be able to access the document because we have parsed it before. Let me just run this to see what we get. Okay, so we should get this error here. See if there's no build errors or anything. Okay. Let's see what is going on here. So we should have gotten like an open thing. Yeah. So we got a did open with the content. Then we got a general protection fault. Okay, that's something else. That is something that happened. Get AST. How did we get another error reported? Maybe it happened after that or something. Because this says document unparsed. Okay, let's try and just restart everything. Go in here, expression. Yeah, it crashes, good. Go down, error. Document not parsed. What the hell is this? Initialize. Is this the client capabilities or something? Yeah. Received message. Initialized. Did change configuration. Okay, so here's like the did open, I think. Did open, yes. And then we get general protection. So okay, so there is something weird going on. I'm not sure how it like is restoring itself from this or something. Oh, it's just a line of code. Okay, so this we get a general protection exception here. That's the error that's happening, not document not parsed. Okay. So we're trying to get the AST. We are trying to do the thing. Okay, so maybe there's an issue with how we did the workspace thing. Hang on, is it document? There could be some invalidation going on. No, wait, the workspace. Where's the initialize? Here. So we are doing this, but the document store shouldn't change position. This should stay the same here. We should just have one document store and that's it. So this shouldn't be an issue here. Oh, it might be something with the arena. Maybe. Or something else. It might be bindings? No. This is stable. This is like a one-shot thing, so it's not really an issue. Actually, no, it's not. It's not. What about the scope? The scope pointers are stable now, so this is not a problem. This is a reference. This though, if we keep bindings around, do we do that actually? I don't think we do. Self-binding. Find in frame. No, that's the interpreter. Semantic lookup. We get the pointer, but then we're not supposed to like use it for something permanent. Yeah, we get the scope here. We get lookup, binding, type expression. That's stable. This binding, we don't. Well, we only use it for type expression. Here we just check if it's not null. Here we just do this. Okay, so we don't keep them around because they are not stable. What else could happen here? The workspace itself, I mean, no. Okay. We're creating, well, this is the environment variable and it's freed anyway. Actually, let's actually do that. And then we don't need to if it. Because if it tries to free a 0 length thing, nothing happens. But if you put something in here, this will actually crash. because it doesn't differentiate. Or is it crashing or a content error? No, I think, why is that not a, that should be like a, almost like a content error. It should be able to detect if this is like a read-only string. I don't know. Anyway, like the compiler should know that, right? Logging enabled. Right, so actually now we have to check if the length is, well, actually we just do that because it's not 0, it's or it's not 1, it's not, that should be yeah, there we go. Okay, anyway, that's not the issue that we're looking at. I'm procrastinating here. I mean, it could be something with the arena. The nested arenas has been messed up stuff before. Not sure why. Maybe the pages get like mixed up. I have no idea. They shouldn't really collide. But I think before, when I tried to use like nested arenas, they kind of write over each other, which is really weird because they should like control their own areas. If you have another arena, I guess it's kind of weird because one arena would have, like, they have a certain page size. Yeah, you have a list of buffers, which are kind of the pages in which we would store things. So it would allocate a bunch of, like, it would allocate one page first and put stuff in there until it's full, and then it allocates the next thing. Although it's kind of weird if you have nested arenas, then the child arena will request like one whole page, I guess. So I don't know. I just know that there has been issues. I'm not sure if it is because of nested arenas or if I've done something else that's wrong. Probably the latter, but you know, it's just been as soon as I have nested arenas, some weird stuff is happening. Anyway, let's try and find something else that might be the issue as well, because I have I can't really remove the arena. The only thing I would be able to do is maybe check if we can send in another allocator that would be specific for the type checker or something like that. Actually, let me check what kind of allocator we're actually sending in here. Okay, LSP main. So we have the GPA server. Okay, that's just the GPA. And then the workspace is initialized here with the, so that's just the GPA. So this is not nested arenas then. I see what's going on. The documents is declared or created here afterwards. But they don't really need, yes they do need. Okay, well, we could also make them pointers, I guess. So we can initialize them here directly. This has an error anyway, so yeah, okay, sure. Let's just make these pointers. Because then we could just make the workspace is allocator create workspace, and the document store is a document store. Actually, LSP document store. There we go. And then we can initialize the workspace with allocator, document store, and that's it. And the document store, we could also reorganize this, how this is done, but whatever. You can see how they are kind of depending on each other here. Okay. And now you're just a workspace and you're just the document store. There we go. And now we don't need to do any of this silly stuff. Okay. You can be an error apparently. Alright. Can you be an error? No. Alright. And right, so now they are not. Yeah, that should all be fine. I'll just restart the whole thing. Oh my god, there we go. Okay, now up to evidence, as we say in my country. Method not found. What? Method not found? Receive message params, text document URI, position. Method is document hover, text document hover. Method not found? I disagree. Oh, it's slash hover, not dot hover, right? Why does it say dot? I mean, I know why, because I copied it from the specification. Hey, we got hover. Well, we got hover in the top scope. Oh my god. Wait, B is int? No, it's not. What the hell? Okay. It's like, I think it's like reassigning B to int here. Okay, and you can even get the types. Wow, something went wrong. Okay, so it's not able to find the alias. Yeah, but that's really nice. I think we can store the information. We can store const. Yeah, we should actually store const information in the binding, because we need to do like semantic check on that. If you try to, you know, reassign a constant, you shouldn't be able to do that. So let's go to run binding declaration. And when we create this, we need actually to know if it's constant or not. So is mutable, and then we create the binding. We actually have to know if it's mutable. And then is mutable equals is mutable. And then we just add is mutable is a bool. There we go. Alright, now we have the information. We need to also add it over here. This is of course not mutable. The globals. You are not mutable. This is like the 4 iteration variables. This is what? This is the type binding. It should always be not. Yeah, it should. It's always a const. That's right. All right, but this one should exist on binding declaration is mutable. There we go. And last one is function declaration is also not mutable. There we go. What is this? Oh, it's, wait. Oh yeah, the parameters are also not mutable. There we go. Maybe they should be actually. It kind of makes sense in Zig maybe, but in here it's like, does it really matter that much? I don't know. Let's just do it like that. Okay, so now we know if it's mutable or not. So we can go to the LSP server, handle hover, and we can say, here we can say like if it's const or actually also what I want to do is I want to say write all runic there we go. Also new line. Okay, and here we'll say like if is mutable, we will print if it's mutable, we'll print var. Otherwise, we'll print const. Oops. There we go. And we go here, and we will restart. And now we get fully highlighted here as well. And this is const my string. Hey, it starts even. It starts to feel like an actual thing. Not sure why we don't get. Oh wait. Okay, I see what's going on. So basically, the lookup that we're trying to do, we should actually do a lookup. Actually, okay, that was the correct thing. Okay, we'll use the location to find the correct scope, and then we have to do a lookup on the identifier that we're on. So we have to do kind of like an extraction of on the identifier, because right now we're just matching where the declaration is. The declaration is up here. We need to match this identifier name and the scope that we're in to find the correct thing. Right. Also, it says int here. I kind of find that funny that we're reassigning the type to int. Yeah, so types are mutable, or the binding type is mutable, I guess. Which is, I guess that's why we don't get an error here. The type gets changed. If we did this, we should get an error. Yeah. Now we get both errors. That's weird. I think it might have crashed now, actually. We restart, it only gets the one. Let's restart it here. No, we only get that. Okay. Okay, I see. If I do this, we're gonna get like a whole bunch. Are we not clearing the diagnostics? Maybe we are. Okay, we're not clearing the diagnostics. We should be. Oh, I see. Wait. Type checker. Invalidate document. We should. Okay, so we get the module. We remove the scope, but we still have diagnostics for it. So, Okay, let's loop. Let's do this. I equals 0 while I is less than diagnostics items length, and I is plus equal to 1 in the end, or in continuation there. So let's get the diagnostic I, and actually, you know what, let's not do this. We're gonna check if the URI is the same, or the path. I'll just, you know what, I'll add a convenience function here for the path. Start file. Just nice to have those convenient stuff. So we can do standard memory equality U8 path against the path itself. If it matches, we will do a swap remove on I and continue. If we didn't get it, we add I to 1. Because basically, if we do a swap remove, then we should also check the item that we were on again, because it could be a new item. So basically, let's say you have two diagnostics, one for, the first is for this document, the second is for another document. So when I is 0, it goes here. The path, this should be true because the first one should be this document. And then we remove that, so we do a swap remove, which will put the second document in the first position now. So it should still be 0. So next time we're looking at 0. We're comparing now against the other document, which should be false, and then we increase by 1, and now it should be over the length, so we're done. Yeah, that should be good, and we don't care about this. Okay. So now we should be clearing the diagnostics of this particular document as well. There we go. Good. Okay. Let's see if we can try to fix this actually. And maybe we'll get to scope, finding the correct scope, and then I have to leave here because it's getting a bit late. So nice. Okay. And also, this bug is kind of funny. I need to. I'll just write it down so I don't forget it. I'll probably see it anyways, but bug when reassigning a variable, the type gets overwritten to the assignment type. Okay. So what we need to do, we need to so we need a utility that gives us the identifier that we are hovering over, which means we need to kind of, if we have an identifier that looks like this and we're the cursor standing over here, we need to backtrack until we get the thing. I guess we could maybe try to find the token as well. Or we could just do a quick, you know, we kind of know how an identifier should be. It's just that it would be nice if the identifier qualifications are the same between the LSP and, you know, the actual compiler, or not compiler, but, you know, parser. So, or tokenizer, I should say, or lexer, whatever. So that's why I'm kind of leaning towards using the token instead of like finding the token instead of trying to. It would be faster, of course, to just read from the source to match the entire thing. But there's just something that speaks against it. But of course, you know, it's not really that big of a deal. I guess identifiers. I guess we could make like a temporary lexer to like parse the identifier or something. Like go back to actually we could take the line. No. Are you using I3WM or Sway? What? I don't know what that is. Actually, okay, let's just do it quick and dirty right now. So, so we can get it working actually, because I need to make this work right now. We can do a proper thing later. Right, handle hover. So we need to extract the identifier somehow. So location. Extracted identifier. I'll just make a function, extract identifier. Wait, where's this? Do we have the source actually? We should have the source in the document store, so we should be able to get the document. Get URI. Well, we do have the URI. Actually, we have it here. Okay, and we should have it. If we don't have it, then there are issues, because we're not gonna get anything actually. So what do we do then? Do we return some kind of empty result? Something went wrong. Yeah, extract. Okay, else no. Okay, so now this should be like a string or no. We're kind of working. It's kind of like working in maybe monad. Okay, so yeah, that's great. Now we don't really use. Well, we are using it over here. Yeah, get scope from block. So that should be fine. We just need to implement this properly, but it should be fine for this use case. The binding though, this is not correct. That is not correct. We should do a lookup instead now. So we don't actually loop through the bindings. We will do scope lookup instead. We'll look up the name, which should be the extracted identifier, except we might not have it. So I will do if extracted identifier. We will look up on that and break that out. And this is also optional, so that's fine. Otherwise, we could do break. No, I don't think you can have same. It's the same. God damn it. Wait, we could do this actually. Let's put this here and that there. Yeah, and if we get down here, we will break. No, there we go. Wait, what? Oh. Actually, you can kinda nest like this, but then you have to have a semicolon there. But that does work. This is kind of like bind in Haskell here. Use of undeclared identifier. Yeah, so we don't have that yet. Okay, so we try to extract the identifier. If we have it, we try to do a lookup. This could also be null. So binding is still being able to be null. So all in all, this whole thing. However, the range can now actually be like, if we have a binding, we should use that. Otherwise, if we have a range, or I mean, if we have an extracted identifier, we should be able to use that information. So actually, this should be like the what should we call this? Like the actual name, but then we also get like a location or a span actually. So then we can say if. Actually, let's do the same thing here. Let's do a break. If we have a binding, we want to break from span. If we have an extracted identifier, we're gonna break something else. Otherwise, we will just break that one. This one will break from span as well, which will be i.span. Okay, so now we just need to make this function here that should return, you know, something that has name and span. Temple OS. I'm not using Temple OS. Maybe I should actually switch to that. I don't know if you can program in Zig though. Does Zig have Temple OS support? I don't know. All right. Yeah. So we need this. We need extracted identifier. Extract identifier. Where we need. What do we need? We need location and text, right? So location. And text or source or whatever, and we should get What was that message by the way? And the compare plugin has gone haywire. I get all sorts of weird errors recently, and I haven't really updated it in forever. I haven't updated any packages in forever, to be honest, or plugins. Yeah, extracted identifier, I guess we can just call it. What is going on? Oh, it's the recording. I'm recording a macro, that's why I don't get the LSP stuff. Okay, and this should be like name and spam. Alright. And this should return an extracted identifier. Oops, daisy. Okay, so basically here what we need to do is first I want to find this offset. Oh wait, that's the wrong, no, it's not the wrong location. To location. So I guess we kind of want the offset now. Find index. But we need the source though. Oh, it's okay. Alright, well, we should have the source, so it should just be a matter of getting it, to be honest. Even if we don't have the offset, we could get it, I guess, but okay. Then this should be the text. Oh, actually... God damn it. Okay, let's just do this. Let's just assume we don't have it. So then we could get the index by doing find. Wait. What the hell? Is it not the same? What is going on? To location. Room location. Oh, I see. It's this guy. The position has find index, not the other way. Okay. I see. Okay, so then if we have the document, we can do location offset equals, and let's make it mutable now. Location, no, it equals params position find index of document text. There we go. Are you a nullable? Okay, so you're nullable, so I guess if we didn't find it, we do 0. Okay, so now we should be able to try and have the index at least. Because if we don't have the text, like if we don't have the documentation, we won't go in here anyway, so. Right, so let's try and find this identifier. So basically, we're gonna see, yeah, this is of course optional. First, we're gonna do is, actually we should have like token No, maybe it's the Lexer. Let's make these public. So now I can say like is. Wait, where is it? Front-end Lexer. Oh, I see, it's on the file itself. Is identity. So now we can use these. So it should be either of these. So let's get the character. Which should be like text offset. If offset is 0, that indicates something is wrong, but I will just go with it here. So we'll get this thing here. If it's start or, well, if it's not start and it's not continue, we will return null. Why is the formatting all messed up here? No, you don't. Let's remove that. Okay, you're a pointer now. Fine. Implicit results. Okay. Then we return null. Otherwise, we will go backwards until we find the start. So while true, I guess, and let's have the start is offset, which is a U size, and I guess well, let's just do this here. So let's also do 1, and start has to be more than 0, I guess, maybe. So if we still have like continue, we will continue, I think. I see Temple always creating YouTube shorts, and I say, what the hell, we write system, but just 30-40k likes. And I search in Google to who has creators, he died like 10 years ago. Yeah, he's like a legendary developer, basically, at this point. He made it, yeah, it's kind of, it's like a sad story as well. It's kind of, I don't know. I don't know too much about the surroundings of like how he died or anything like that. But I knew he had like mental issues. But he made this. He was like, yeah, he had this mission from God to create this operating system, and he just made it. It's actually quite incredible. And he made his own like programming language and compiler, and yeah. And he was quite yeah, I guess, yeah, he streamed and stuff like way back. I haven't watched too much about it, but yeah. Okay, so start going backwards. If we continue, we still go back. Let's have this in a thing. I have this here, so we protect against underflow, I guess it's called. I don't know. It's basically protecting against going below 0, because this is an unsigned. And if we get to 0, I guess we won't get there since, but it's just for safety, since this goes like over 0. If we are at 1, this still runs, and we decrease to 0, and next time we're at 0, then we return. So we can't go further back than 0, basically. And if we still have this continue, we continue to go backwards until, yeah, but potentially we could probably go back into non-identifier mode. So when we're out here, we will, well, if we don't continue, we should just break, I guess. Right, and then we do a last check here. If we have a start, because potentially it could be like a small difference here. That's not, actually this is going to be start. If start is not start, we have to increase this by 1 to get back to the actual start. Okay. And then we basically, now we can just use the Lexer actually to get a token here. Potentially we could do, you know, to get a little bit of a thing. So actually we could do this, and then allocator. Oh, well, okay, let's do self. I'm just gonna do that. Yeah. This would be self allocator. The file is, well, the file name doesn't really, well, it might matter actually. Well, we have the file here anyway, so the source is text, but now we need to, let's actually start from the start, because we don't care about this, the rest at the beginning there. So now we have our Lexer, right? Or now we have our Lexer, and we just get the next token, and this should be the identifier token. So we should just return, if it's not an identifier token, something has gone very wrong, I guess. I mean, technically it could be, I guess, yeah, I guess actually we can check like the tag. If it's an identifier, we will not get it, but we will return, actually we can return directly. We will return name is token lexeme, and span is token span. Okay. Also, we need to deinitialize this thing. Let's see. I forgot if we actually do anything with like the source. The source we shouldn't really do anything with. No. Okay. So if we have an identifier, we take that. Otherwise, we could get like some kind of keyword actually. So if we get a keyword, we don't really, you know, you could get the information, I guess, about the keyword. But yeah, for now, I'm just gonna say that everything else is a null. All right. Cool. So yeah, so this is kind of robust now, since we're using the lexer to actually get. The only thing that's kind of iffy is like this backwards tracking to find the start of the identifier. So yeah, that is because this could potentially change in the lexer how we deal with identifiers, which would change this whole thing maybe. So but yeah, anyway, extract identifier, yes. So you want self now, that's fine. And I guess, are you, well, we're doing a bunch of tries here. I guess if we can't get these, we just return null. There we go. So we don't really, you know, we don't care if it fails, we just return null. So we don't have to try here. All right, there we go. What's going on here? U8. Wait, oh, I see. So character now, start character should be text start. Actually, let's just put text start here. Same thing here. And you need to be a var. There we go. Okay, so now potentially, yeah, we try to extract the identifier, we get the source of the document, we still get the scope here the same as before, but now instead of finding like the declaration location, we're doing a lookup instead of the name and use that to get the binding. Yeah. And then we, yeah, and then we also could use the actual extracted identifier if we don't see anything. Like if we do this, we don't actually, like in this NeoVim here, I don't actually show like the hover highlighting of the thing that you're trying to look at, because it's like, to me it's not really point. I don't know, it just is there and I don't care. But maybe for like, if you have like visual, no, wait, visual code, is that how it's Visual Studio Code? Is it Visual Studio Code or, yeah, it's Visual Studio Code. It's not Visual Code, it's Visual Studio Code. Why do you use negative or equal? Why not just or equal? Do you use negative? Let's see, where are we? Here, you mean? Because I need to reassign start. I need to set sign or start to be. I need start to be decreased. If I did this doesn't really do anything. I think this is kind of, this could be like a bitwise OR assignment. So that doesn't work here. I need to decrease it by 1. If I did this would just like toggle. No, this would just set the first bit to 1, and then we would have like an infinite loop. I think if we do this, then we decrease by 1. It's not a bit operation. This is not a bit operation. This is like modifying the minus operator. It's not a bit operation. We're still subtracting by 1. But the difference is that if you reach below 0, it's gonna stay at 0, because this is an unsigned type integer. It's an unsigned integer, so it can't go. If you go below 0 in Zig, there's a safety check where each time we go below 0, it's gonna crash basically. And I don't want to do that, so I have a safety here when decreasing an unsigned. In this case, I don't want it to go below 0 basically, so I will add this one. Now there's another one where you can use, that's I'm not sure what this is called, but this is like wrapping behavior instead. So if you go below 0, now we're gonna wrap around to the maximum value instead. And I guess it's kind of like you're having like the mod operator here mixed with the minus or something. But yeah, that's why that's how that works. Which I really like it. It's a really cool, you know, operator. And Zig is the first time I've seen that. Not sure what other programming language has that actually. Okay. Let's see. Let's build. Let's do a test run here. Okay. And let's go to the file. Let's do LSP restart. Okay, nothing crashed. Good. This still works here. This is still saying int. Does this work now? Hey, it works. What do you? Okay, that crashes, so we cannot find that. Okay, let's start it up again. Okay, now we can check these. Awesome. Man, that is a nice feeling actually. It works. Okay, well, the string doesn't work because it's like a global it's, you know, it's not really described anywhere. I think it might crash because we're trying to open like a file that doesn't exist or something. We don't have support for things in global scope. Basically, it's defined in kind of like, it's defined in some sort of in-memory global scope. Oh, integer overflow, interesting. From location. Location line -1. Oh. I know what's going on. The spans actually has like line and column. So, okay, we're kind of this. Okay, the span, this, or the location rather. The locations here actually, we can assume that line and column always has like at least, you know, 1, and then when we transform it into a location in here, the position from location, we subtract 1, but since they were 0, that actually doesn't work. So if we add these, now it should work. Okay. We even get the actual source or the actual definition here. Damn, man, that's awesome. That is awesome. Except it's not correct. You can see it's kind of weird. Like it's saying that the type of my string is a string. That's not correct. It should say equals actually. Okay, that's nitpicking, but we could easily fix this now. We could go to the type checker, but we need more information in the scope actually. So we have to go to the scopes, and we have to go to the binding, and we kind of have to, well, actually we don't really need more information because the identifier should start at a capitalized, yeah. We could actually do this. We could add is type identifier boolean self identifier return self return standard ASCII is upper self name 0. Just safety. So we don't get a crash and have to debug the thing, go back here and add this later. Okay. Now we can go to the LSP server and we will go to somewhere here. So first, whoops, did I say? So first I will print, actually let's do write all identifier name yeah, and then it's like if identifier is type identifier, we will write equals, otherwise we will write that. There we go. Wait, unused argument. Oh. There we go. Now it says equals byte, and these are type annotated. Very, very, very cool. Should we fix this bug here? The last thing we do, so we'll lean in kind of a clean state here. The only thing is like let's demonstrate the scope thing. So basically, if we have this is in inner scope, inner scope, and let's just set it to something here. Now this one is not found because it's not in the outer scope. In outer scope. This one is found. It should be found anyway. Something went wrong. Okay. Let's do restart, I guess, maybe. Why is something going wrong? God damn it. Something went wrong. Okay. New text. Type checker failed to run under unsupported type expression. Okay. What? Unsupported type expression. Okay, let's just set it to something else then. There we go. Now it worked. Something went wrong. This one we get. This one we don't, since it's in the scope. This one we don't get. This one we do get. I'm curious, does this work? Yes, it does work. Even if this is like kind of like a, it's not really a parse error actually. What if we had something like this? We have a parse error. Okay, now it doesn't work because there's some weird issues here. The parser actually doesn't provide an AST for us, for the type checker to check, so we don't get errors. Actually, we don't get any errors, I guess, because something goes terribly wrong. But yeah. Yes, I'm going to sleep now. Okay, I'm just gonna fix this last one. This one. Or do I? No, I don't actually. I don't need to fix that. So I'm just gonna write this down with the scope thing, because the inner scope doesn't work. I'm gonna write that down in the to-do type checker. Yeah, I guess this is kind of part of the type checker. When finding scope by location, properly return the innermost scope found. There we go. All right, but yeah, that can we now? I mean, we're kind of working on this one, I guess. I will remove you. Finds outermost scope. Very trivial implementation, but hey. Okay, so, and we also got the hover thing to work, so that should be like on the LSP. Do we have like hover anywhere? No. Let's just add this. Basic. Okay, so let's do like hover. And we have like basic hover implementation. Yeah, just like identifier lookup. And we still want to have also like go to definition. That should actually be, once we have the hover in place or the scope, inner scope thing in place, go to definition should actually be possible to do probably. What else things could there be for that? Okay, well, I'll just have to check the LSP documentation to get the thing. Okay, I just wanna, you know, put these things down here so we don't forget what we've done. Mark down. Ah, that does work now though. No, it doesn't. Actually, well, yeah, it does. I don't know. Bug takes, yeah, this still is a thing. Document links, yeah. Parser, yeah. We're this is in progress basically. I'm gonna put this here in progress. Also, this one is also kind of in progress. Yeah. Type checker. Yeah, the function stuff. There's a lot of things I want to get to. So much to do, so little time. Okay, cool. But the good thing is, it feels like I can't tire of this project. So that's great. All right, well, good night. See you later. Thanks for joining.